Data science involves many techniques for harvesting raw data and summarizing it into knowledge to share with others. Let me tell you a little bit about myself. I'm Dr. Kat, and I'm a product scientist. My job is involved with product development and making intelligent product decisions by using data science techniques to detect emerging trends. I find Python a wonderful language to prototype ideas and experiment with new software designs. I live and work in New York City, and when I'm looking for an apple to eat, I go to the grocery store in my neighborhood, which is a few blocks away. Or if I feel fancy, I go to the farmer's market for some organic apples. But our apples come from a farm somewhere kind of far away. A farmer or distributor has made sure that the apple took all the steps along its path from the tree that it grew on all the way to the store. So the job of a data scientist is similar in overseeing the steps involved in moving data from its raw form into its consumable form. It starts from the collection of raw data and preparing that into data samples and packing the patterns you find into reports with charts and such. There are so many steps, and when you have a lot of data, it can become very complicated. So because of that complexity, many people have created software applications and code, including Python libraries, to provide tools to make all of this work easier. Python is a great language to start with, but we still need to know how to think like scientists to go through the steps with precision. The purpose of that is to have the ability to consistently reproduce our work, especially our calculations and our data sampling techniques. We want to be able to verify our findings time after time. That precision is where we can most confidently report our work. The usual workflow for conducting these projects generally starts with asking the right questions, framing the question so that you can define what needs measuring, selecting the appropriate data for measurement, and cleaning that up, and then finding the patterns to extract key points. It takes practice to move through all of these stages seamlessly, and sometimes you'll circle back to select new data and clean that up, and maybe you'll realize you need to do more cleaning. Selecting your data source is very important. It's better to select data after you've defined what you're looking to measure. That way you avoid over-collecting or under-collecting. Accuracy is always important, but the amount of precision you need during analysis really depends on the conditions of how you'll be reporting your findings. For example, on one end of the extreme, in the world of academic publishing, you're conducting research studies for peer review, so there are more rigorous guidelines for selecting datasets because they care a lot about precision. On the other hand, maybe you're testing out a small data sample and want to do that quickly. Or you're working with the clothing retailer who may want to know a ballpark figure of sales information, just to get a feel for the amount of attention given to each product. For instance, maybe a shift from light to heavy fabrics, such as t-shirts to sweaters, suggests that the season is changing and it affects what people want to buy. That said, keep in mind the context and the conditions of what you're reporting and to whom you're reporting. Here are some things to keep in mind as part of your data selection criteria. Your data contains a representative sample of all the factors you're looking for. You've decided whether to work with purely quantitative data, which is numerical figures only, or whether to include qualitative data, which are descriptions or observable traits that are not easily measured, such as colors and smells. You've decided between primary or secondary source. If it's a secondary source, it's like buying a used car. You should definitely know where it comes from, how it was collected and maintained, etc. A variety of sample methods are used to ensure representativeness by incorporating an element of randomness in selecting data points. Some common ways are called simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Simple random sampling is when everyone in a group are given numbers and placed into a hat. Then Bob randomly picks 2 numbers from that hat and records them. He then returns those numbers and chooses again, which gives the whole population an equal chance of being selected at each draw. Stratified sampling happens when the population is grouped by a characteristic, for instance, age or zip code, and then one person is chosen from each group to make up his team. Cluster sampling is when groups can be made based on a characteristic, like where they live. For example, we can pick one zip code and only look at individuals in that group. In this course, we will be analyzing men's ties, which come in many different styles. By the end of the course, we will have written Python functions that let us easily see how styles and brands are priced, depending on the print and the material it's constructed from. In case you're not familiar, here are some examples of styles available. Popular styles for the prints are called Paisley, a droplet-shaped design motif that dates back to the Babylonian civilization, polka dots, dots spaced evenly for a consistent pattern, sporting, logos or emblems printed on the tie, solid colors, a solid spread of color, plaid, a grid-like pattern, striped, parallel lines typically of the same width, differing in color or texture than the surface on either side of it. Along with these styles, we'll also consider fabric and price. Data is either collected slowly over time as it becomes available to a database you set up, or downloaded from a source of curated datasets. An example of a dataset archive is the open access government data from data.gov. But you can also get data via public APIs from social media sites. For this introductory course, we're going to start with the smallest dataset so that you can experience the data science principles without buying a supercomputer. By the end of this course, you'll learn how to analyze the prices of ties based on their characteristics. The data for doing this analysis is from a comparison shopping engine called ChopStyle. They provide an API for developers to connect with their data called ChopSense. While you could use Python to connect with their API, I've already provided a CSV file for you to download and use, but feel free to check out the teacher's notes for tips on how to get data directly from their API. The data prepared for you to use as you follow along with code examples in this course come from a comparison shopping engine API. These bits of information describe each type: brand name, which is a string, the product name, which is also of string type, the price, which is a float, which is a kind of number with decimal points, and also the material, which is a string type of either silk, cotton, wool, or cashmere, or other, the print, which is also a string, which could be polka dot, plaid, striped, or solid, and the image URL, which is also a string type. I'll be using Workspaces for all of our time together. If you hadn't had a chance to check out the Python Basics course, definitely take a quick peek to see how to use Workspaces and familiarize yourself with basic Python syntax. Let's jump over to Workspaces and start exploring. We're using libraries that already exist in the Python package index because it's available and will help us quickly bootstrap and start our project. If you have a local installation of Python on your computer, you might need to type in a few commands into your console to install some libraries. In Workspaces, you should already have the libraries needed for this course. First, create a new workspace with the Python environment. Once you're in the environment, you'll see a console at the bottom half of the screen with the blinking cursor. That's where you type in commands and run Python files. We're going to be using a few libraries. We call them external libraries because it's external to our data science project. You can double check to see if you have these installed. We're going to use a bit of command line regular expressions, and you can see that we already have the ones we need for this course. When you need a library that's published in the Python package index, it's really easy to install it by typing in pip install and the library name. However, we already have the ones we need for this course. We'll be calculating a few things and creating some files in this course. And let me show you a demonstration of some outputs. And just as a reminder, when you create any sort of images or CSV files or PDFs with Workspaces, you'll need to download the workspace and open up the files on your computer. Are you ready to roll up your sleeves and write instructions for the computer? We're going to be writing functions to get our raw data into better shape. This will help us prepare the data to make our later work of creating reports easier. Imagine for a moment, thousands of bushels of apples are picked, but a lot of them need to be looked over to separate the good apples from the bad apples. In the processing facility, you'd have workers looking over each apple and washing off dirt and having the twig trimmed just so. Loading your raw data into data structures is important because you're telling your computer where the data is on your machine, what the structure of the data is, and what should be defined for calculations. The data for our exercises throughout this course is available in data.csv, and we will be using Python code as a way to speak with the computer to provide instructions on how to read the data. Let's open up a data file with Python using the built-in CSV module. Let's first create a new file. So let's first import CSV, and then let's create the function. We pass in one argument of the file name. We create a list that we return. Now let's open up a file name and use the UTF-8 encoding, just in case there are any special characters that maybe have an apostrophe or accent mark. We never know with these brand names, they might have foreign characters. Once we open the file, we can use a CSV reader to read in each line, and we're going to save the output of that to TyReader. And I'm just going to make sure the delimiter here is set to tab because our data has tabs. And then for each line in TyReader, or each line in the data file, we're going to append that, we're going to add that line into our data list that we return. So this will then give us a nested list. Oops, I want line here. One more thing that I want to do is, just in case we have different types of delimiters, I'll pass in a value here, and I'll set the default as tab, but then I can pass in comma or semicolon, etc. And that way it's an optional field. And if I forget to add something, it uses tab. And if I have another type of formatted file, I can use that. All right, now we are ready to try opening up our text file. So we're going to use a variable, data from CSV. And we're going to say open with CSV, and data.csv is our file. Let's print the header from this file. And before I run this, I'm just going to quickly show you that our file, I'm using Vim to show you that our first line has these words separated by tab spacings. And when we read with our function, we're going to have it converted to a list. So let me show you that really quick. So that's how our output should look like. And just as a note, the delimiter here recognize the tab spacing as the place to split each column. So that's how we got a list. Once we have our data in a data structure, and in our case, a list of lists, we can use the concept of creating copies for extracting smaller samples to work with. Let's review a simple sample of a small list. Roy G. Biv. Roy G. Biv equals red, orange, yellow, green, blue, indigo, and violet. And rainbow equals Roy G. Biv. We're going to create another list, warm colors, which contains the first three elements of rainbow, and that would mean red, orange, and yellow. We're going to create another list, basic colors, which is Roy G. Biv from the first to the fifth element, but every other one. So that would lead to red, yellow, and blue. Wasn't that fun? We're going to take this simple pattern of copying list elements into nested list elements with our dataset. Each of the rows is an index inside the bigger list, starting from index 0. Each row itself is a list, and the end result is almost like a map of grids. That's how we can tell the computer exactly what items to work with. Are you ready to see some more cool tricks? We can keep on writing functions for all the repetitive actions and pass in a file name argument instead of rewriting everything. It's like laying down train tracks and allowing a train to get to where it needs to go. If you're new to writing functions, you're in luck. There's some other videos in the Python Basics course that cover these concepts. I'll show you another snazzy tool for working with data. It's called Numpy. It stands for Numerical Python Extensions. This library was designed in 2005 to increase speed and flexibility in working with large datasets. Since then, in the past decade, there have been other libraries created, some with really nifty features that make data analysis super sweet. But we're going to take it slow and steady and cover the basics of a classic, well-known Python library. Numpy provides you with a function to help you generate Python data structure from text, with some options for describing how your text file is formatted. The common ones are describing the delimiter. It's usually a comma, but it might be a tab or semicolon, and passing in the header information, such as the header name and the data types. We're going to try using Numpy now to open text files. And what we can do is use the Numpy generate from text function. Actually, let's import Numpy. Let's create a function, load data, passing in the file name. And we want to use Numpy generate from text. And we want to pass in the file name and the delimiter. We're going to use an optional delimiter value that's passed in. And let's say we want to skip our header. So skip one line when we read the file and provide our own. And then also we have 3 more things to pass into this Numpy function. First, we want to say if there are any invalid errors, we don't really want to hear about it right now because we just want to try to read in files. But we do want to pass in names for our fields. So I'm just going to set a constant value here that we're going to define in a moment. And then we're also going to pass in data types so that we know if it's a string or a float, etc. So that equals data types. And actually, I have a typo. And I also want to remove these quotes because I don't want the string field names. I want the variable field names. I'm going to save this as my CSV. That way I could just return that variable. All right, now I'm actually going to copy and paste some values. First of all, I'm going to copy and paste in here field names. That is the same list as what was outputted before, except I changed the word from print to pattern for the second to last element. Now the other constant we want to enter here is data types. And this would be defining the data types for each of the fields. So we have the integer type, float type. Integers do not have decimals, whereas floats do have decimals. We also have the string types, which could be A for any or S for string. Right, so now if we were to run this function, we'll now have a global variable called myCSV. And if we were to run this one script again, oops, I have a typo. Oops, another typo. There we go. It should be D-type singular, not plural. And there we go. We're going to next work on printing the size of this. So
To prepare our workspace, we're going to type in clear to make it easier for us to read the console. And then I'm going to close our file.
Now we try to describe this data set. For example, how many rows are there in the data? What is the average price of ties in this data set? We're going to start with finding the size of the data sample.
Here's how we can show the number of rows in the data with one of the built-in list functions, length. I'm going to quickly show you using the Python REPL. If we have a list, apples equal 1, 2, 3, and if we were to say the length of apples, we have 3. We're going to use this concept to count how many ties we have in our data sample. I'm going to import everything from our first file. And then I'm going to use length of data from CSV. But I actually want to be able to repeatedly call this, so I'm going to use a function number of records and pass in the data sample. So instead of data from CSV, we're going to get the length of the data sample and pass in data from CSV later on. I'm actually going to change this to a full word number. And we'll call this maybe number of ties. None ties. Okay, that should not be it. We want to say, oh, yeah, we definitely want to return the length. So, and also we want to make sure that we don't see that later on. So let's go back to our file and let's comment out the print. All right, close that. Clear, and then we'll say Python s2v2.py. 5051 ties in our data sample. But remember, our first line in our file was the header, so it's actually 5050 ties. So what we might want to do is say -1, make it spaced very nicely. And we have 5050 ties in our data sample. Clear. I'm going to close that file.
It is essentially counting the length of the list, data from CSV, with one of Python's built-in functions. It also means it's telling you how many index values are in there. The total number of rows in our data, including the header, is 5051. Since the data is stored in a list, let's quickly look at a few more useful built-in functions for lists. Sort. This helps you sort items of the list in place. It only modifies the list and has no return value printed. Reverse. This reverses the elements of the list in place. List.count x, the number of times that x appears in the list. Append is very useful. List.append x is how you write it, and this adds an item to the end of the list.
Let's try an exercise to see how to work with lists. Let's try to sort and count the number of green apples in 2 bins. And let's first open up a Python REPL. Oops, just Python. We want to say that my apple bin has several apples. And then maybe your apple bin has green and red apples as well. And we want to know how many green apples we have. So let's say my green apples equals my apple bin count green I have 3 green apples, and your green apples you have 4 apples that are green. So how many do we have total? We can print my green apples plus your green apples. And between the two of us, we have 7 green apples. With Numpy, we can find the size of our data sample using their size property. Let's create another function called define number of records 2. And we're going to pass in the data sample. And let's return the data sample.size. Now remember, you're going to be working with the Numpy data structure. So this won't work for a nested list. So let's print out the output again, and we have Python s2v2. Oh, I need to have the function names exactly the same to have it to work. So let's print that. With our Numpy version, we said to skip the header when we read the text file. So that's why we didn't have to include this -1 in our return. To add up the values in one column for this dataset, we want to loop through the outer list data from CSV, and then grab the third column in the inner list each time we loop through it. So let's create a function that would do this. We're going to import our functions from before. We're going to pass in an argument for the data sample. And then within this, we want to have a temporary total number. We want to return the total. Now let's loop through the outer list to get each row. And we're going to go ahead and say starting from the second row. That way we can skip the header. Now the price is going to be row 2, and then we're going to make it a float type just to make sure that we can work with it as a number. Each time we go through the list, we're just going to add that to the total. We have here that it says 0, which is not what we're expecting. So obviously we have an error. Let's actually make the total be the sum of price. There, that looks better. I'm going to comment out the lines from before that show the number of ties in our samples. And then now we're going to print out the sum, which was this number. I'm going to clear this. I'm going to quickly show you a couple of ways to write a more condensed form. We're going to use list comprehension, and so it'll be a more succinct version. So we're going to copy that just to quickly type this up. And we're going to remove this line because we don't need the total. Instead of this loop, what we're going to write here is for x in data sample, and also we're going to use the third value of x, and we're going to turn that into a float. So what this really ends up being is, instead of the row here, that's where it is. And instead of using total equals price, what we can do instead is the price total is equal to that line. So it removes these three lines and we return that. Actually, we want to sum up this list. So we return the sum of prices. And that's how we get a more concise version of code. So I'm actually going to comment this out very quickly so we can move on to the next example. So I'm going to show you another kind of list comprehension. And this time we're going to use a lambda function. So once again, prices equals a one-liner, which is a list. We're going to map over the data sample. And what we want to do here is use lambda x, so the lambda function. And we're going to get the float type of the x2. So of each row, basically. And again, we're just going to return the sum. And that'll give us the exact same number. So we can print that out. There we go. So now I'm going to comment it out again. And now I can show you NumPy's sum function. With NumPy, you can use numpy.sum, and it's very similar to this Python's built-in sum. We're going to be super certain that our prices is float type. So we're going to convert the whole list of prices into float. We're going to use a list comprehension. We're going to say float each line for line and price. And the total will be equals to numpy.sum. and prices in float. And what price is equal to here, price is equal to my CSV and the column price label. We're going to print this out. We're going to print out the my sum, and we'll see that the value is the same, but they've truncated it for us.
The mean, or the average, depending on how you want to call it, can easily be calculated with a simple formula. It is the total divided by the number of records.
Let's start with creating a function, find average, and pass in the data sample to the function. So I'm going to first clear our workspace and create a file. I'm going to import everything that we've done up to now. I'm going to comment out the print statements. We're going to reuse our functions from before. We're going to be using the total to be the result of calculating the sum. Then we also have the size, which equals number of records of data sample. Average equals total divided by size. And then we return the average. We're going to pass in our data from CSV into this find average function, and then we're going to print out the results. To avoid using the square brackets, let's add a second argument to the function. It'll take a Boolean value to indicate whether the data sample has headers. The default is false, which makes it an optional argument. But if it's true, it means we want to skip the first row. Another thing that we can do is to return a nicely formatted average with just up to 2 decimal points. So we can do that with the string formatting function, and we pass in the settings for 2 decimal points. We have a typo. And there's our answer. I'm going to comment out this line. Just a quick note here about types. Calculating the average number requires division, and division can only be done for number types, not characters, not Booleans, nor strings. When you divide a float by an integer, Python will accept this, but keep in mind that it returns a float. So if you want to end up with an integer type, you'll have to convert it afterwards. One really quick way to check the types for your variables is to use the built-in type function. So let's look at the types of a couple of values that we've created so far. So in our first one, we have the average price, which is a float. Our data from CSV is a list, and our myCSV read in data using the numpy's generate from text function. So that's a numpy array. Now it's a handy trick to use this type for when you want to figure out why your calculations might be off. If we were to convert the average price into an integer, you'll see that it will show a number that's rounded down. So you can see the first number has the decimals, and then when you use integer, it converts it. So definitely check your types if you feel that your calculations might be a bit off. Let's look at one more example for calculating the average. Let's try dividing our data sample in half. So let's calculate a midpoint value and say our ties are just divided squarely in the middle using the midpoint value. We have number of ties from our other file, so we're using that number and dividing it by 2. And then we round the midpoint value just to make sure it's an integer. Python lists require you to enter an integer value to represent the index. We're going to use a string here and print out the inputted values of our first half of the average is 0 to midpoint. We want to say that the data sample does have a header, so we're going to have a true there. Then we're going to copy that, and the second half is from the midpoint to the end. And there is no header. That's the average of the two halves. We can also make sure that our output is formatted to just 2 decimal points. There they are. And further add symbols and such to make it more readable.
Maximum and minimum values are different from the previous types of metrics. Instead of providing a figure that takes the whole range, it provides a number that represents the end of a range. In the last section, we worked on calculating the total and averages. Both of these measures take into consideration the whole range. Here, instead of the whole range, we look at the minimum or the maximum value. We only want to grab the element relevant to us. It's quite often just one value. The maximum value is the greatest element in a sample. Similarly, the minimum is the smallest element in a sample.
We can use Python's built-in functions for lists to find the maximum and the minimum values from a list. Since we're starting with a list of string elements, we have to convert the data types to float. The max and min only work with number types. We start with creating a function findMax, and we pass in the data sample as well as a column number. In our case, we want to find the maximum of price, which is the third element. And then we'll take the price and append it to a list, and then we'll find the max from that. You could use a list comprehension to make this a more condensed form, but this is a little bit more readable, so I'm just going to use this to show you how it works. Now, so let me print this out so that you can see the output. So we have 7, 11. So let me comment out those lines. Clear. And run it again. The most expensive tie in our data sample is 711. Let's find the minimum. That would be just the 2 characters changed. And also those 2 characters changed. And let's see what the least expensive tie would be. $10. One thing to note here is that we have this list repeated in both functions, so maybe we can try to truncate our 2 functions into one. So let's create something called findMaxMin. I'll take in a data sample as well as the column number, but we're also going to have a value for the minimum or max. I'm going to call it M. I'm going to actually have 2 temporary values inside this function, and then I'm going to repeat that for loop from before. I want to look at every single tie in the data sample and pull out the price for each tie. And then I'm going to check whether the condition that was passed in equals to max, or maybe the condition was equal to min. But we also just want one last one, just in case the input was not max or min. If it's max, we want to say the value equals maximum of the list. If it's the minimum, we want to say that the value to return should be the minimum of that list. Oops, we have a typo. We should add in the R. All right, so we definitely need the third argument. But just to get around this error in the future, in case we forget, We can set the default value to be max. And we can say we want to get the minimum, just for now. We forgot to pass back the return value. There we go, we have $10 tie. Let me clear that. All right, so that's what returns from that function. Now let's move on and see how Numpy calculates the maximum and minimum. Numpy provides functions that make it easy to get your maximum and minimum as well. So what you would do is say numpy max equals numpy.amax, and we're going to say prices in float. We have price from before, that was the price column from the Numpy array. And then we also said that price in float was a list comprehension where we converted the x for x in price. So if we print out the Numpy max, we'll get 711. And then we can also do the same to get the minimum, which is replace the max with min. And if we were to print that, we'll see that the number that comes back is the minimum value. And there we go. So I'm going to remove that line so that when we import this to other files, it won't be distracting.
In this stage, we'll be exporting data into files, in case you want to save them for future reference or open them up in a different software, such as your favorite spreadsheet application. CSV stands for comma-separated values. The CSV format is a very common data format to export or import data. Most spreadsheet and database applications offer export and import for CSV files. CSV files generally store tables of data by fields and records. Each field in the record is separated by a comma within the CSV file, and generally new records start on a new line. This is what a CSV file looks like that has been exported from Excel. Writing to a CSV file is just as simple as reading from a CSV file. The CSV module in Python provides a write object that allows you to write and save data in this format. The syntax and parameters of the write object are very similar to the syntax for the read object. The syntax for the write object can be expressed as csv.writer with the CSV file name and the optional formatting parameters. The writer function of the object is initialized with the csv.writer statement. The CSV file argument is used to indicate the name of the CSV file that needs to be written into. The dialect argument is optional, but it can be used to specify a format for the CSV file output. The second parameter, formatting params, is an optional parameter that allows you to specify the format of the data to be written.
We're going to write some code to write out data into CSV formats. Let's see what it looks like. Now we already imported CSV in our first video, but we're just going to do it again here so that you have the visual reminder to use that. Now we're going to write a function here. We're going to say write to file. We're going to pass in the file name, and then we're going to use a data sample. We're going to use the CSV writer object And what we want to do here is say open the file name. And we're going to use write. The encoding we're just going to set to a universal one just to be on the safe side. Dialect we can say is equal to Excel so that it can be imported by Excel. And so let's write every row. Here, let's export our silk ties into the data folder. And say stage 4 silk ties. That was a typo. And now let's try it again. And what I'm going to do is list everything inside the data folder that starts with S4 and is a CSV file. So we have here the silk ties. Writing out data to files is useful for when you want to save a copy on your hard drive. And you can use it as an attachment to email to someone else, or it's just easier to read in files later if you want to work with a smaller data sample. Create a new file. I'm going to import all our work from before. I'm going to create a function here. Oopsies, there we go. That will let us easily write out the brand and the price, just the two columns, into a text file. I'm going to write out two variables here, the brand field index and the price field index. Just in case I don't remember what they are, I have them assigned here. I'm going to have a list here for the new array, which will contain just 2 items per row. And the way that I'm going to create that is by saying for each record in data sample, I'm going to say that the new record has 2 elements. And each time I am reading a new record, I create this new one, an empty one, and I assign the 2 elements here. With the first one being the brand. And the second element would be the price. And we're going to append that to the new record so that we could return it. At the end of this, we want to write to file. We're going to try this out by printing the Gucci ties into this file s4 brandandprice.csv. We want to avoid typos since that would give us a hiccup. Let's see if we have this file, and we're just going to list everything in the data directory that matches brand and price. And yes, it is not a file size of 0. There's actually some data in there. We can actually use this bash command, cat, and say we want to read the file. we just want to preview it. So we're just going to say we want to read the file name. And it's just everything Gucci with the brand and the price. I'm going to clear the console real quick. I'm going to write another example now that exports the minimum and maximum rows. We're going to reuse our functions from before. We're going to find the max min. And now as we read through our data sample, we want for each record in the data sample to check if the float equals the minimum or the max. If it matches, we want to keep that record, so we're going to save it to the new array. And of course, at the end of reading the whole data sample, we want to write this file out to a file name. And this is how you would use this function. You would say write min max CSV, and you would pass in the file name that you want to write it out to. And then you would also pass in the data that you want to have written. Let's write another function that just abstracts the first function and just writes any two columns that are passed in. Again, we want to make sure that we create a new record that has only two elements. And instead of using the index defined, we're just going to pass in the index that we pass into the function. We save this new record into a new array, and when we're done reading the whole data sample, we write to file the new array. We can specify the new array gets written into the file name that we specified. Now, before we were using 5 and 2 for brand and price, and as an example, I'm just going to use 3 and 7 to indicate the tie name, the product name, and then also the product description. So I'm going to run that. I want to make sure that a variable name is not 2 words, but rather just 1 word. Oh. Great, I made the same mistake in 2 functions. All right, let's clear that and run it again. So we have those files created.
Sometimes we find a wonderful way to share data that's not a spreadsheet. But sometimes life gets in the way and we have to use the Excel format when sharing documents. Luckily, we have a tool at our disposal for these situations. There's a Python library for reading and writing spreadsheets. It's called OpenPyExcel. The CSV Writer module will only write CSV files. You cannot create an Excel formatted XLS or XLSX file with the CSV Writer. To write out to XLS or XLSX formatted files, you will need to use OpenPyExcel or similar libraries.
You can install files from the Python package index using pip install and then the package name. And once you have it installed, you could then import that library at the beginning of your Python files. So I'm going to clear that console. I'm going to create a new file for this video. Import OpenPyExcel. And then we're going to go ahead and import from OpenPyExcel some items that we're going to use here. We want to import the workbook object. We also want to import the Excel Writer object. And then also one more helper function from OpenPyExcel to help us figure out what column letter to work with. So we're going to create a function called SaveSpreadsheet. To use the function, we're going to pass in a string argument for the file name because we want to know where to write out the file. And then we also want an argument for the data sample. So it's still standard like all the other functions we wrote for this stage. In order to use OpenPyExcel to write spreadsheets, we have to first create a workbook object and then an active worksheet, or define an active worksheet. So WB equals workbook and worksheet WS equals workbook.active. Next, we work with nested loops to export the data cell by cell. So in a grid-like pattern, very organized, systematically writing out the output. Excel uses letters to go across columns A through Z and numbers to go down the rows 1 through however many rows. The first loop that we're going to write, the outer loop, will let us work with one row at a time. And then the second and inner loop we write will help us work with one item of each row at a time. We're going to work with variables to figure out the column index to get the column letter. We're going to start with 1. And then each time we get to a new field, we want to get the column index to also increase. So we're going to plus equals 1. And then, of course, we want the outer loop to increase the row index as well. Now, the column index and the row index are really important when you write out to the worksheet cell. We need that information. And we're going to use the string formatting function as well. We're going to pass in 2 values. The first value will be the column letter, like A. And the second will be the row index, like 1. So A1, and then B1, C1, D1, etc. I want to set that value, the cell value, equals to the field that we're currently reading from our data sample. At the end of this function, we can now save to the file name. We're going to test out this function with a new data sample. Let's try a new brand, Keton. Let's save our file into the data directory, and let's say s4 ketonties.xlsx, Python s4 v3 .py. Oops, I have a typo. I think it was filter column by string, not defined. Oh, we need to make sure we import all the work that we did before. So let's also import from s4v2 import all. Oh, yes, it was filter column by string. I clear this. I believe I have another typo. Oh, actually, I don't want this in there. I want this outside there. We can't open spreadsheets on Workspaces, so what we have to do is go to File, Download Workspace, and download our project. So with this file, you could probably open it in something like Google Docs. But that's how you would be able to access your Excel spreadsheets. All right, let's clear this console again and close the file now that we're done.
In this stage, we'll be working with the Matplotlib library for creating views of charts and tables. Matplotlib comes with functions that allow you to create all sorts of chart types, but today we're going to cover a few of the basics: line charts, bar charts, and tables. Line charts are known as plots in Matplotlib. You can use the module plot to indicate the x and y variables, such as colors, labels, and other properties such as line width. We're going to use the Ggplot style sheet instead of the default styles.
Let's create a function, and let's call it create line chart, and input all the settings that we're going to need for creating line charts. We'll take a double list data structure and a title for the chart, plus a file name to export the chart image. It'll be nice to pass in user-defined values. That way we offer some flexibility. I'm going to create another file and import from everything before. I'm going to import Matplotlib as well. When we use Matplotlib to create plots, we first create a figure object. And then we create an axis object within that, and we call that AX. And we're just going to put it at the one position, just that one chart alone. So 1, 1, 1. We're just going to quickly use this one line to convert all the prices into an integer and sort it. Let's see what would happen with float. I'm actually not sure if it will work, but let's try it out together. We're going to quickly create an x-axis labeling with ticks, a list of 0 to the number of items in the sample. And then I'm going to quickly type out everything else that we need to label the figure and make it clear what we're looking at. And after setting all these settings that I'll explain later, we're going to save this figure using savefig, and we're going to use the file name that we're passing into the function. Let's make a list comprehension for x2 for x in Gucci ties. So we're going to use a list of price elements, just the price, just that column. And we're just going to pass it a title. There we go. Sometimes we still need to skip the header. That way we can avoid these string to float conversion error messages. So I don't think we're able to look at images from Workspaces, but the file has been created. So let me download that actually so that you can look at it. And there it is. Now, there's something to keep in mind with line charts. The representation of prices may not be accurate because there might not be any price at certain price points. And if that's the case, it'll look like there are ties, but maybe there aren't. So a bar chart's actually better for displaying the number of ties at each price point. I'm going to clear the console, and I'm going to close this file.
These line charts are misleading since there might not be any ties at a certain price point, so it would be better plotted as bar charts. Let's see what a bar chart would look like for plotting all the 5,000 or so price points. As you can see, the bars are squeezed together. That chart contains over 5,000 bars, so it's difficult to see. Let's try to create a clearer chart by grouping prices into buckets of price ranges.
So we have here the function that plotted all the bars into that difficult to see chart. What we want to do is to group price points into groups and then plot bars for those groups. And the way we do that is in our create bar chart function, we pass in price groups, and we'll calculate that somewhere else. And price groups is going to be equal to the output of this function, group prices by range. We're going to provide a list of prices and group them. So how do we do that? So in our group prices by range function, we're going to pass in the list of prices. We're going to use the counter object to count up number of items. So as we go through the 5,000 or so prices for each item, we're going to get the rounded price. And then we'll say, if it's under $50, we'll put in the first bucket. If it's between 50 and 100, put in the second bucket, and so on, to have 7 different buckets. And then at the end of that, we'll know for 7 different bars, how many values are in there. So with that, we can then create the bar chart and save it into, let's actually make it in the data folder. So let's quickly go over how that function works. Again, we create a figure and we create a subplot in the figure. And we also have the colors set to cycle through the colors. But there's one thing I do want to do, which is to make this look a little bit nicer. And I'm going to do that by adding a style sheet. Matplotlib gives you a few options. Ggplot is one of them. So let's do that. And we have the labels here for the different groups. So we're going to go ahead and label them here and then have a grid, and we're going to save it to the exported file name. Oh, actually, I meant to save it into charts. So let's actually clear that and run the file again. And so that file has been created. I'm going to open up the file so that you can see what it looks like. So let's download the workspace. And I'm going to clear this really quick. And there we have the chart in a grid background.
Sometimes showing data in a chart doesn't provide enough context nor details. So we want to use tables to show a more detailed view of specific characteristics of each data point. We have a few ways to draw tables with Python.
We can use Pretty Table library to display a simple chart in the console. We first need to import the Pretty Table module, and then we can use it to create a Pretty Table object. And we want to pass in our data sample. And we're just going to use the header first to set up the header of the table. And then next we want to add in lines for each row of data. So we want to say add row. And this is Pretty Table's function, add row. And we're going to add in a list. Actually, instead of data sample, let's just have an empty, no arguments. And then just say this list is going to have style for style of tie, comma. And our second list item would be average price. So in our first row, we can work with print ties. Let's test this out first before we try to finish printing out every tie style. Let's make it a nicely formatted average price number. So we'll just call a function pretty average. We'll pass in a number, my number, and let's say we want to find the average of my number. And we also want to return the formatted 2 decimal points. And we save that to pretty average, so return pretty average. And what we want to do here is say pretty average and then print ties. And now we can add in more. For instance, solid, Paisley, striped. And we also want to update our data samples to match what we're printing. So now we have 4 data samples. We're going to print one more for the brand type. So we're just going to say find the average of Gucci ties and print the pretty average of that. And if we were to clear the console and run the file again, we will see that the average is printed like that. Oh, let's actually add a $sign. So let me say clear and Python S5v3. And so there you go. Now we could potentially pipe out this output into a text file, but this text file isn't really that pretty for printing out or sending as an email attachment. However, Matplotlib does offer some features for outputting PDFs. So let's look at those features. First of all, you're going to have to import the Matplotlib library. And then you're going to work with that. So since we already have this from before, I'm just going to erase this line. I'm going to copy and paste some text from before that I've worked with. I'm going to add in some code that I've written just to make it quicker for us to jump into this. So we're going to have a function, count prices for brands, which is used by build table text. And also I want to paste in the function create table, which would be our utility function that creates it. We want to make sure the indentation is correct. Now, there's just one more utility function that we need that would help us create groups of prices. Right, so let's have that. Then let's print out the table. But before we begin, we want to get the brand names. So let's just grab the brand column from my CSV. And then we want to specify the column headers with the price ranges. So let's say the first one is 0 to 50. And then the following ones are $50 increments. Let's just do that real quick. And then we'll have a temporary data file to save 2 columns, just the brand and price. And then we'll actually create the table. And we're going to pass in the brand and price, which is just the brand and price information for our data sample. The price groups would be what we found before, which is how many ties in each price group. And then we also pass in the brand names and the column headers. And we say we want to save the file into S5 prices in table.png. Okay, so I need to actually save the file so that we can run it. And I'm going to type in python s5v3.py. And it turns out I have an indentation error, so let me quickly fix that. I have another typo. Was the file created? We can look at the chart folder. And we can see that it's a file with something in it. So the best way to look at it, once again, is to download your workspace and then view the files, the image files on your computer directly. It's going to be in your charts folder. We named it price and table, so I'm going to open that up. And what we have here is just the ties whose price is discounted compared to their usual price.
In the last few videos, we covered how to calculate and export images. It's important to remember that the end goal to most data analysis projects is to share your findings. Let's make charts easier to read and prettier. We're going to work on creating printable reports that you can share. First, let's label our chart so that your reader knows what's being displayed, and to better understand what data was measured. Here's what I mean. See this chart? It's hard to tell what's being measured, right? Let's take a look at the chart again with labels. Now we know what the units of measures were and also what the chart is about.
Matplotlib provides you with some functions for editing the look of the chart, including the title, the labels, and the legend. Let's revisit code from stage 5 that creates a line chart in the function createLineChart. The highlighted lines here in the code show in context how to set the values of the title and the axis labels. Matplotlib needs you to create a chart first before editing these properties. If I set the x as this is the x and the y as this is the y, we can try calling the function again. This is the title. And that would be the second argument. So we would have, let's call this labels.png. And the data that we want to pass in, let's try jcrew ties. Oh, we need to import that. Get the prices. So list comprehension. We have to download this workspace to see the file. So we have this is the title and number of ties and tie price. So there's one thing we need to do here that's different. Let's do a 2. That way we make sure that it's this one function that we just wrote, not calling the one from before. We want to set these custom values. So let's see what happens when we create that. Let's download the workspace again. And we can see that the values have changed. This is the title, this is the X, and this is the Y.
Next, we can take these charts and export them to PDF formats, which can be printed out or sent as email attachments. You know, the usual large email attachments that require Adobe Reader. Well, we want to make sure we can still interface with folks who are heavy PDF users. So we're going to create some PDFs with Python. You can use Matplotlib again and directly move your plots into PDF pages. The key steps to saving PDFs are to import the PDF Pages module, create a new object of PDF pages with a file name, save figures, and close the object. So now through this course, we have covered how to take data from CSV files, taking only the stuff we need, and then displaying them in a concise manner in charts or tables. Now we've come full circle and we will be creating reports.
Let's look at an example of creating a 2-page report. I've written a couple of functions and will demonstrate to you how to use Matplotlib to create PDFs. First, we have to import the Matplotlib plot module, and then we have to import the Backend PDF pages module. And then let's import everything from before that we've created. The first function that I have here is plotting a graph. And here I have set the figure and the colors and all the settings. And then I create bars that take in the data and I annotate it with data labels. And then I included legend, and then I remove distracting lines, just so that when we print it, there's less colors and it's a cleaner look. I also remove ticks from the X and Y axes, and I've labeled it. And then I return that figure at the end of that function. I have a second function here for plotting a graph with a table. And again, we have the figure and the axes defined, and then we also define a table. Now we're going to be using these two functions to plot a graph and then a table. So these are two separate outputs. And what I'm going to do here is first create an object pp equals PDF pages. And we're going to set the file name is my report. So let's first make the first plot, which is the output of plot minimal graph. We're going to pass in the price groups from before, and then we're also going to pass in the columns. And then we want to save that plot into our PDF object. So plot 1, and we want to have the margins tidy. So we're going to use the bbox inches equals tight to keep the margin spacing minimal. And now we're going to work on creating the table. And again, we're going to have to build the table text. We're going to reuse our function from the last stage, building the table text. We're going to pass in the brand and price data, just the two columns, and we're also going to pass in a list of brands. And our plot 2 is going to be using the second function, plot graph with table. And we're going to provide the table text. And our first element in the tuple is the table text itself. And the second element of the tuple would be the row information, which would be the first column, all the brands listed. We're also going to pass in the columns for the headings, for the table to have headings. And let's also save this second plot with also the margins being in a neat and tidy style. And of course, we're going to close this PDF object at the end. We want to close the stream because if we don't, we can't open the PDF. So that's all we need to create the PDF. And let's run it now. So, oh, I have a typo. Save figure. And if we run that file again, as a reminder, we have to download the workspace to see the file, the PDF file that we just created. And here's what we just created in my report.pdf. On our first page, we have a bar chart. Let me zoom in to make that easier to view. Our first page is a bar chart with legend and the gray background removed. There we go. The first page is a bar chart with the legend and with the gray background removed and the tick marks removed along the top right and left. It shows the pricing allocation of all the ties in our data sample, and it's basically the same chart we're working with before the stylistic improvements. And I removed most of the colors and lines just so that when we're printing, we use a little bit less ink. On the second page, what we created was a table with 7 columns, showing the brand name in the first column and then various categories of prices in the other columns. The sample data comes from the Stage 5 examples on creating tables. And what's being shown here is any potentially discounted ties. For example, Dolce & Gabbana tends to sell their ties between $100 and $250, with a lot of ties over $250. But they do have some ties that are priced in under $100. And so that's the end of our screencast. We've created a PDF with 2 pages, and we've reused the functions we've been working with from creating plots and tables.
And now, finally, we have something amazing. We can put all of the code we've written so far together. By layering the functions we have written, we can write coordinating functions or little robots. Once we've written functions with instructions on how to do things, then we can create functions that execute those instructions. Thanks for watching. I hope you enjoy this introduction to data science. Analytical thinking combined with hard data can help you convey your messages to your audience about what you're demonstrating. Labeling any figures to help guide your audience can avoid confusion. Python gives you wings, but remember to stay grounded. Try to break down your tasks by writing functions and following the PEP8 style guidelines and being precise in your definitions. You'll thank yourself later. For example, say you want to filter by brand name for one report, but in the next you need a filter by material. By having one function that filters the string type fields, it allows you to pass in different arguments depending on your search criteria, which can mean that you avoid repeating yourself with the tasks and just pass in the arguments for different strings. Everything we've covered in this course will be easier to code with the Pandas library as it contains built-in functions. Now that you understand the concepts, you're ready to try out Pandas and more advanced features of Matplotlib. Now that you've finished this course, here are some projects you can try. You can download more recent data from ShopSense. You can create more reports with the updated data, and you can compare the reports from 2 different time periods to see if the tie prices have changed. Go out, have fun, and enjoy the fruits of your labor. When it comes to describing our tie by the type of fabric, we have a lot of different options. But how can we easily identify the ones made with a Cashmere blend? We can look through the description and see if it lists Cashmere.
We're going to create a function now that creates a new column for our data of Boolean type. Let's go ahead and open up a new file. Let's import our work from the previous. There we go. Okay, so let's create a function, create Boolean field from search term. And let's pass in the data sample and also the search term. And we're going to pass back a new list that we're just going to call new array. We need to make sure that this new array, which would be the new column, has the data header. We want to make sure that this new column has the header of the search term that we're looking for. So let's add that in. So it's new array.append, and then the data samples, the existing set of headers but we want to add one more at the end. So we want to append Cashmere, or search term, I should say. When we create a new column for our new data sample, we want to have the headers from before, but adding in the new column's header. So we do that by taking in the data sample's header and adding to the very end of the list the search term. And then we add that to the new temporary array, just so we have it in there. And now we can go through the rest of the data sample, all 5,000 or so lines. Starting from the second row, within this loop, we're going to set the Boolean value. So first of all, we're going to default to false. If there is a search term in what we're going to have as the description, we want to say it's true because it exists. There we go. And whatever that Boolean value is for the new field, we want to append it to the row. And then we want to save that row into the new array. Right, so this will build up everything that we have plus the new column. Okay, let's try running this because this will be really, really fun. Okay, so we have my new CSV equals create Boolean field from search term, passing in the data sample and our search term. So that didn't actually filter it, but it did create the new field, right? So let's see how to filter so that we can actually count the number of Boolean values and say how many of the ties match the search term. So we're going to have to create a new function. And this function, we're going to call it filter column by bool. And we're going to pass in the data sample and the column number of the Boolean. Actually, instead of filtered rows, maybe we'll call this matches search term. And for each item in data sample, starting with the second row, if items search term column matches the value true, if it is true, if it exists, or if it's true, then matches search term should include that item. Append item. And at the end of that loop, we want to return all the items that matches search term. Okay, now we can say here, number of Cashmere ties equals my new CSV and then filter that. Filter called by bool. So we want to filter that, and then we want the number of records in that. Now we want the number of records, and we can print that. And let's see how many Cashmere types we found. Oops, we forgot the column. We want to say column 11, the last one. We have 56 ties that were made with Cashmere in our dataset.
Now we're going to try writing simple functions to filter rows of data. Filtering is helpful for when you want to look at a subset of data. It is easier to work with smaller samples. This chopping of data becomes more important as your dataset gets larger. For example, if you have the starting dataset as 1,000,000 rows, then chopping it down to 1,000 will be quicker for your computer to process. Sometimes it even helps you to better test models that you're working on. It is easy to extract small samples with Python. You can copy lists and filter a subset. Similar to writing match conditions for strings, we can also write match conditions for Booleans to filter columns with number types.
The filter function, like we saw in the last video, it takes a list of lists and a field name, the column number, and it matches the filter condition. We were working with Booleans, but now we're going to try working with strings and then later with numbers. So let's create a new file. Let's import everything from before. And let's create a function called filter column by string. I want to pass in the data sample first of all, and then the field, and then the filter condition, because we want to actually know what the string should match. And we're going to have filtered rows as a temporary list, and then we're going to return that. Yeah, let's make it plural. That makes sense. Okay. This time, instead of passing in the column number, we're going to try to look for the column number. So let's say column call equals the integer of the header row. Let's look for the header row where the index is matching the field. And then let's add that into the temporary list. We want to make sure we keep the header in our resulting data sample just to keep things consistent. All right, we need a for loop now to go through each item in the data sample, and we're going to filter that to see if it matches the filter condition. So for item in data sample, starting with the second item, which is the data, not the header, if the items column index, if that item matches the filter condition, you want to keep that. You want to keep that item, so you're going to add that to your temporary list. So let's keep that item, and then it'll be returned when we return the temporary list that matches items that match the filter condition. Let's try finding silk ties. So silk ties equals filter by column by string. We're going to pass in data from CSV. And let's search by the material type that matches silk. whoops, we're printing out everything. We want the length of the silk ties. Or rather, the function we created, number of records. So let's clear this and let's run it again. Found 3,382 silk ties out of the 5,000 or so. We can do something similar with this, and let's look for wool and cotton. Wool ties and also there's a lot more silk and wool than cotton ties. Okay, let's also try reusing this function for, oh, actually let me format. Let's make everything look better with the code really quick. So we do something similar as this, but we can find brand names. So we want to know how many ties are of Gucci brand that are being sold here. So we have the same data sample, but this time we want to filter by brand name and Gucci. Let's see, how many have we found? So let's see, found that many Gucci ties. And we're going to say return number of records of Gucci ties. Okay, so we have the parentheses matching the right number. We have 171 Gucci ties. Now I'm going to clear this and then comment out the print statements, and I'll show you how to filter by the number types. Clear, and there we go. I'm gonna do that. Clear that actually. Okay. So we're going to create a new function that's very similar. It's, instead of filter column by string, we're going to filter by float. We're going to have the data sample again and the field. And we're going to say a direction for greater than or less than. And then the filter condition of the number that it should match or be greater or less than. Again, we're going to have a temporary list, and we're going to return that list. Oh, let's make it grammatically correct. Once again, we want to find the column index number. And we want that to be an integer because you need an integer to access indexes in a list. We also want to make sure our condition is of the float type. Now we want to actually go ahead and try to match each item with the conditions. So we need a for loop. The element to match should be a float type and then the row with the column index. So this would be the price or whatever number that you're working with. If the direction is less than, then we want to use if element is less than condition, and filtered rows append row. So we'll be repeating that. If the direction is less than or equal, then we want less than or equal. And we're going to keep continuing this. Oops. And we have one more condition here for equals. And if it doesn't match any of these, we want to just pass. Let's try out this function, and let's try to find ties that are all less than 20 bucks. Oops, we want to make sure it's ties, not tiles. Let's see if this works. Whoops, we want to have not the list. Let's clear this. We want the number of records. We want the number of records, and that would be like that. Python s3v2.py. So we found 38 ties under 20 bucks, and that's pretty awesome.
In the last section, we talked about filtering rows, where we only show ties that match a certain condition. When grouping rows, it's about combining ties that match a condition. To help illustrate the subtle difference, let's look at some graphics. Filter is a type of selection that refers to restricting the result set to contain only those elements that satisfy a specified condition. Grouping refers to the operation of putting data into groups so that the elements in each group share a common attribute. The following illustration shows the results of grouping a sequence of characters. The key for each group is a character.
Now let's move on to writing functions for grouping. For example, we can look at how do prices of Gucci ties compared with J.Crew prices. Well, we can look at the maximum prices for each brand. So we filter by the brand, and then we find the maximum and the averages. Let's create a new file again. And from let's create a variable, Gucci ties. Okay, now we have filtered data samples of each brand that we're interested in looking at, and now we could find the maximum values for each. Remember how we had this find max min from before? We can reuse that as well. Actually, we can leave that blank because the default is max. And let's print out a string message equals maximum brand type price is dot format, and then let's pass in the arguments. So we want to pass in the brand, which would be, actually, let's do it that way. Let's have a string, and then when we print, that's where we can pass in the values. So we have message dot format, and we pass in the brand. Here we're interested in Gucci first, and also max Gucci. Let's see if that works. Okay, let's use this just to make sure. Oh, right. Okay, so this error happened because price label is actually in the header. So let's remove that. And we can still use max min. And let's see. Oops. Let's just use this. Oh no. So I guess jcrew does not have a space. So we could do that. Remove the space. Clear console so we can more easily read it. Alright, so maximum Gucci tie price is $545. Oh my god, that's pretty expensive. Let's try another brand. Let's see how jcrew's ties compare. And it's a little bit less expensive. Okay, so now let's try averages, because if the maximum value varies so much, maybe the average also varies a lot. So we have average Gucci, which is equal to average, find average was the function name, find average. Let's look quickly again at the functions. Was it this? It was just the data sample and whether or not there are headers. Let's close that. So we want to say true, there are headers. And we want to print the message. And let's actually change this so that it's 3 arguments passed in. And then here, instead of maximum, we could say average. And we could reuse all of that. Cool, right? Average price is $165. Let's see what the jcrew average price might be. Oops, there we go. And here we want to use jcrew ties. And here we want to, in the message, print out jcrew and use average jcrew price. Okay. Oh, so the average price of a jcrew tie is lower than the average price of a Gucci tie. And we can continue doing this and also compare the prints and other information. So let's try one more exercise. Let's try printing out the print. So Paisley, stripe, solid, or print. Let's see what that looks like. And lastly, we want to look at the solid ties. So we have 4 different patterns to look at. Oops, I have a typo here. All right, so let's see what happens when we print out that. So we didn't finish the parentheses. It needs to match. Okay, so there we go. It worked. Now let's actually print out all 4 of them. Instead of the message from before, we want to use tab spacing. Oops, we don't want to paste that. We want to copy this and have the same order of prints. Okay, now let's print out this and see what it looks like. All right, we only want 2 arguments. We only want 2 arguments here, so we actually want to remove this. When we print it again, there we go. So we have the tab spacing making the alignment look nicer. From what we can see from this is that print ties are not cheaper than solid ties.